More than 40 million tons of oil are extracted from offshore rigs every year. And to maintain that enormous output, humans must build structures weighing hundreds of thousands of tons in the middle of the ocean. Constructions that challenge waves, wind, and seismic forces. Few people realize that before a drilling platform can stand firmly on the water, each of its components must be manufactured on land, inspected down to every weld, and then towed thousands of miles through ice to be lowered precisely onto the seabed. Behind that colossal structure lies a chain of geological algorithms, multi-layered steel architecture, and equipment that must operate reliably in an environment where even the smallest error can cause disaster. From gravity-based foundations and topside installation to the moment the oil rig truly stands firm in the deep sea. Offshore oil rigs have long become cities that never sleep in the middle of the ocean, taller than the ships passing by, operating silently 24 hours a day, 7 days a week. And over the past 500 years, the demand for oil has consistently exceeded supply. Oil is not just a fuel, it is the backbone of modern civilization, supporting transportation, electricity, healthcare, industry, and nearly every daily human activity. When pipelines and onshore oil wells could no longer meet demand, the petroleum industry began expanding into deep waters, developing drilling platforms to extract crude oil from the seabed using hydraulic technology. But the farther we venture from shore, the greater the challenges become. At depths of hundreds of meters, water pressure can crush steel, the seabed constantly shifts, and ocean storms can knock down even cargo ships. Therefore, oil rigs are designed as closed technical ecosystems, as solid as the foundation of a building, as flexible as a ship, and as precise as a laboratory. Only when every component operates flawlessly can the structure remain standing in the open ocean to extract the energy that powers the modern world. The oil and gas industry has developed many types of drilling platforms, among which the two most important groups are fixed platforms and semi-submersible platforms. Two design philosophies that are almost opposite. One relies on absolute stability, while the other depends on the flexibility of buoyancy. In waters as deep as 1,700 feet, fixed platforms are used. These structures but also operate continuously in temperatures that can drop to minus 44 degrees Celsius. To sustain the daily life of hundreds of engineers working long shifts, the platform is equipped with amenities such as a small cinema, a billiards room, a gym, and an internal cafeteria, all arranged like a self-contained town in the middle of the frozen sea. These extreme conditions make Burket a symbol of Arctic petroleum engineering, a structure, the central control room, the blowout prevention equipment, and even the crew living quarters. Each module undergoes load testing, pipeline checks, structural inspections, and storm condition simulations before being combined into a complete topside. Only after passing all these verification steps is the topside cleared to be loaded onto a heavy lift barge for its journey to sea. Once the two parts are joined, engineers proceed to connect the wells, pipelines, electrical system equipment. Every sensor and every pipeline must pass simulations of storms, ice, and extreme seabed pressure before the platform is officially ready to drill wells that reach several kilometers beneath the ocean floor. The most important story lies in what no one can see: how Burket maintains safety in an environment that is constantly shifting. Triggered for real. In addition to fixed structures like the Burket platform, semi-submersible rigs are used for waters as deep as 12,000 feet. These rigs are supported by large floating pontoons. The pontoons provide buoyancy, allowing the entire structure to float and be towed to different locations. Some rigs are even equipped with thrusters beneath the pontoons to assist with movement. To keep the rig in its designated position, anchors are used. When the rig reaches the correct location, the pontoons are gradually flooded to hold them below the waterline. The working deck remains above the surface, while most of the rig's mass stays submerged. If the pontoons are not ballasted down, the rig would become unstable in rough seas. The construction of a semi-submersible rig begins at coastal. The topside is assembled at another facility with all oil processing equipment, power generators, the control room, and crew living quarters, with each module tested and certified before integration. When everything meets the required standards, the pontoons are floated and towed out to sea, while the topside is installed using either the single lift or float-over method, completing the shape of a floating city in the middle of the ocean. On semi-submersible rigs, maintaining stable operation in deep water is a constant challenge, as the structure exists like a floating city that is always moving with the waves and wind. The entire system must maintain an absolutely balanced state, from the ballast tanks that adjust buoyancy to the three-dimensional motion sensors that run continuously to keep the rig in the correct position. Any imbalance can spread throughout the entire system, so everything is highly automated, yet still supported by manual oversight from on-duty engineers. When an abnormal situation occurs, the rapid response mechanism is activated, pressure valves close, processing modules are isolated, and the position-holding engines switch to a minimum energy mode. This protocol is standardized for all semi-submersible rigs to ensure that the structure can operate continuously for many months offshore without needing to return to port. And although each type of drilling platform operates differently, the oil or gas under high pressure that could lead to a catastrophic blowout if not contained in time. Once the oil is successfully extracted from beneath the seafloor, it is continuously pumped into a network of pipelines that transport it back to land. These pipelines, laid along the ocean floor, are known as subsea pipelines and are responsible for carrying the mixture of oil, gas, and water from the wells to shore. Inside the pipeline, pressure and temperature are tightly controlled. In areas where the seafloor terrain is complex, the pipeline is anchored with steel frames or buried beneath sediment to protect it from ship impacts and strong currents. Thanks to the coordination of all these protective layers, oil can travel from offshore wells to the mainland every day while maintaining absolute safety. The energy extraction capacity beyond the limits of land. As traditional oil and gas fields gradually decline, these deep ocean structures allow access to reserves buried beneath the seabed, a strategic energy source that helps many countries sustain economic growth, stabilize industry, and ensure long-term energy security. Each platform generates thousands of jobs and activates entire sectors such as steel fabrication, shipbuilding, marine transportation, technical services, and energy technology. At the same time, it secures the supply chain for thousands of essential products made from petroleum, from plastics, fertilizers, and pharmaceuticals to construction materials. From a geopolitical standpoint, the journey of building an offshore drilling platform is always something to admire. The most visible aspect is the sheer scale and boldness of these offshore projects. To construct a structure capable of surviving in the middle of the ocean, people must combine knowledge, discipline, and a rare level of perseverance. Whether you see an oil rig as a machine that produces energy or as a symbol of engineering capability, the most important element is the enduring effort of those who work behind the scenes, the people who keep the entire system operating safely in an ever-changing environment. Building a platform at sea is not just a story of steel, concrete, or machinery. It is a story of how we push beyond natural limits to meet the needs of a rapidly growing world. And no matter how technology evolves, our curiosity about how things are made will always connect us. Like and subscribe to Mandarin Tech if you want to continue exploring the megastructures shaping the future of humanity.